Mr. Ahmed here. 11.6, volumes of pyramids is our goal. We are going to find the amount of space that a pyramid takes up. The pyramid will have a base of some sort, either a square, could be a rectangle, could be a hexagon, could be a pentagon, could be a triangle. But the base is what it sits on, and it comes up to a common point. All of the faces around the outside of a pyramid are triangles. To find the volume, we will take 1/3 the area of the base, capital B, times the height of the pyramid. The height of the pyramid, we're going to call that capital H, goes from the top down to the base at a right angle. Okay, top down to the base at a right angle. So if it was coming down the side, that is actually called a slant height. We will use that when we find surface area. Okay, we don't actually use it for volume. So capital B is the area of the base. So you're going to actually have to find that area. Tough one's going to be if it's a hexagon or if it's a pentagon. Height is the height of pyramid. Has to be right angle with the base. Okay? So it has to be at a right angle with the base. So, hopping into our first example. I have a pyramid. It appears as if the shape of the base is a square. The height of the pyramid is 12. Now the key volume equals 1/3 area of the base times the height. So I have to find the area of the base, capital B. Capital B is equal to a square's area, 10 times 10, that is 100. Okay, so volume equals 1/3 times 100 times the height, which is 12. When you type in the 1/3, I would probably put that in parentheses as well. So 1/3 is in parentheses. Parentheses 1 divided 3, close it. And then I'm also, should be a little better view here, 1/3 times 100 times 12. And we get 400. And our units are cubed, we are in centimeters. So when you type that in, just looking at that again, make sure you put the 1/3 in parentheses, times 100 times 12. And we got it. Moving on. So this example is a little bit tougher to find the volume of the pyramid, mainly because the shape of the base is a hexagon. So in order for us to find the area of the hexagon, we have to know the apothem. And in this case, rather than reviewing our special right triangles and all of our trig with the distance learning piece, I'm just going to tell you what the apothem is. And in this problem, the apothem is equal to about 10.39. Okay, so that's what the apothem is. It's about 10.39. Keep in mind the apothem goes from the center of it to the edge at a right angle. So to find the area of the base, it's 1/2 times the apothem times the perimeter of the base. It's going to be a regular hexagon. All the sides are congruent. So 1/2 times the apothem, 10.39, times the perimeter, 12 times 6, is 72. Okay, so that is our perimeter. So this will get us the area of the base, and I'm going to type that in. 0.5 times 10.39 times 72, and we're at 374.04. All right, so if you do have a regular polygon, formula 1/2 times the apothem times the perimeter. I will not give you one where you don't know the apothem and can't find the perimeter in this current instance. So volume equals 1/3 area of the base times the height. Well, we know the height's 20, top to the bottom, at the right angle. Plug it in what we know. Volume equals 1/3 in parentheses times the base, 374.04, times the height, which is 20. So this is going to be a pretty big one. All right, typing it in. Make sure you put that 1/3 in parentheses. 1 divide 3, close it, times 374.04 times 20. And we got 2,493.6 centimeters cubed for a volume. And our last one, it gives us the volume. It tells us that the volume of the pyramid is 120 cubic meters. And it tells us that it has a square base. So I'm going to draw a quick little pyramid here with a square base. All sides are congruent. And it comes up to a point for us to have a pyramid. I'm not getting real in depth on my drawing here. There it is. The height would go from the the top, down to the base at a right angle. So I got that marked. Now we know that the volume is equal to 1/3 area of the base times the height. And we are told that it has a height of 10. So I'm putting my 10 in. There's our height. Our volume is 120. Now in this case, since the base is a square, we're trying to find one of the side lengths. So I'm going to let the side be x and x. All sides are congruent. So the volume is 120, and that's equal to 1/3 the area of the base. Now in this problem, the area of the base, since it's a square, is x times x. It is x squared. And the height is still 10. And we need to solve for x so we know what one of the side lengths is. So my first step, let's see here, I'm going to times both sides by 3 to get rid of the 1/3. Times by 3, that'll cancel out my 1/3. 3 times 120 is 360. And that's equal to x squared times 10. Divide both sides by 10. And we get 36 equals x squared. Take the square root. And x is equal to 6. So each side is 6 meters. And that is it for today. Have a good one.